Hello, I'm trying out this new feature today where I'm in a little box, a little circle here I can move around. Very exciting. Okay, let's get started. So, day 11, cosmic expansion. We have a grid of galaxies, and unfortunately, space is expanding, resulting in the ultimate heat death of the universe, where everything will be a total void and no life or really anything will be possible. But that's not for a while. So we get to solve a few problems in the meantime. Um, Basically, this grid is going to expand at these points, and our job is to find the distance between galaxies after this expansion. Um, I found yesterday slightly challenging, so maybe today's designed to be a little simpler. Who knows? Step one seems to be okay. I'm sort of muddling around with how to implement it, and I've put this together. So this is the trial, without any expansion. This is the initial input that we get. Um, I'm going to run you through an example of uh, how I think we can do this. First, I'll just talk you through the rough approach, um, which is let's say we want to find the distance between galaxy 8 and 9, which is here. Or actually, let's go with a different one. Let's go with 1 and 7. Yeah. So let's start with 1. We'll get the coordinates. And in fact, let me get rid of a bunch of this stuff. Let's go away. Goodbye. So we get the coordinates. Galaxy 1 is going to be 3 and 0. And Galaxy 2, or rather Galaxy, we're going to go with 7, aren't we? Yeah, let's go with 1 and 7. Galaxy 7 has the coordinates 7x and 8 on the y. So these are our coordinates. To do this, we've got this sort of expansion here. I've worked out here what all the gaps are going um, down, that's the y gaps, and going across, that's the x gaps. So you can see we've got 2 as a gap, 5 as a gap, and 8 as a gap. So given this, we can then calculate, I think it's called a convolution. I'm not, don't quote me on that, but I believe that's what we've got, or what we can do, in that if we have a relationship between a pre-expansion coordinate and a post-expansion coordinate, then we can translate the pre and the post. And I'm going to do this. You could do this through a function. I'm looking to minimize the amount of processing I'm doing because I'm just getting funny feelings about processing for this task. So I'm going to pre-calculate a map essentially of uh, prior coordinates and then the convolution on the x and the convolution on the y. So let's run through what this looks like. So if we want to calculate the distance between um, G2, let's actually circle these, not using that horrible style. Let's use a blue. 2 and 7. Let's say we want to go between, no, G1 is what I wanted. G1 and G7. Let's say we want to do this. Then what we're going to do distance G2 to G7 can be defined by the convolution of G to and G7. And what I'm going to use this little arrow to stand for is called the Manhattan distance. If you've not come across that, all it means is if you are in Manhattan and you've got blocks and you can just go left, down, you can go up, down, left or right, the number of steps it's going to take to get between these 2 points. You don't need to work out any of the diagonal stuff because essentially it's just the same as going all the way down and all the way right. Nice place, Manhattan. Very simple mathematically, I suppose. So what this means is if we then calculate that convolution, so let's just work through it. So we've got this is going to be the same as G and 0, 7 and 8. And what we need to do now is perform the convolution. So for the x, we've got 3. And for the y, we've got 0. So what we need to do now is add up these, 3 and 1. That makes 4. 0 and 0 makes 0. Don't know why this is a weird error. There we go. And then the convolution of 7 and 8. Gosh, they're running over each other. Ugh, horrible. Okay, 7 and 8 is going to be 7 plus 2, making 9, and 8 plus 2, making 10. The distance is defined by the x's, the difference between the x's, that's 9 minus 4, plus the difference between the y's, 10 minus 0, which then gets us 5 plus 10, 15. And let's hope this is actually the correct answer. Okay, so we're on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 12. 12 on there. Oh yeah, plus the expansion. So let's actually look at the other one. Let's get the other one in here. This is the real one. Okay. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that works. I mean, it's really not that complicated. I'm just trying to get like a kind of a rigorous understanding of it, I suppose, or I'm just messing around. It's probably what I'm really doing. So this seems like a good algorithm. So if we fully flesh it out, well, actually, I'm just going to jump straight to modeling the state. Okay, so my state is going to have a grid. It's going to have a all right, let me think this through. So this grid, we don't actually need this grid, right? What we need is What are we going to represent grid as? So grid we can have. Grid is going to be a list of galaxies. So we're going to need a vector. Gosh. Swear I had a utility for this. Oh well, doesn't really matter, does it? It's not that hard. I should add it to my utilities list though. Okay. Galaxies is going to be a set of vectors, I think. Well, list would be slightly more convenient. Yeah. The reason I want a list is because I want to, if I have sequence in there, it's easier for me to not duplicate the calculation. Okay. Then we want to have our X gaps be a list of ints. This is going to be a list of ints. We can probably have the convolution here as well. Just make sure we don't accidentally make ourselves recalculate that. Okay, and then the distance. I think let's have a space. Then we can have our galaxies as a list of I think I'm going to go with galaxy here and then have galaxy be a simple just in case you want to add something to that later. Okay. Just have this be private. We'll calculate it eagerly when distance starts. Okay, and then what's this going to be? What's the actual thing we want? Sum of the lengths. For this, I think I'm going to have have a generator there just to increase reusability. And then I'll have some length sort that out. And then I'm going to need a bars line and a calculate. So from this point, we can make a plan, which is vec galaxy space. Okay, pretty straightforward. Now I'm going to shift screen share to the editor, move my little bubble across. I think she can go over there. Maybe I'll have her here. Why not? Have fun. Okay. There we go. What am I sharing? Is everything working properly? Yes, it is. Okay, reset the timer and let's get started. Hmm. I'm going to add a method on here. Okay. Well, that looks good. Swap these over just to make sure it's nothing weird's going on. Okay, looks like we're still good. Hmm. Okay, I'll fix that in a moment. So we're going over the x's at the moment. This is an inefficient way of doing it, but I think it'll be okay. What's going on here? That'll do. Okay. I've seen if there's a fancy way to do this with dictionary, but there's not. Okay. If ax is in self x conv. Hmm. Yeah. Irritating. Horrible. Terrible. Just garbage. Oh dear. All right, if that works, I'll be amazed. Okay, what a mess. Okay. Fine. Well, everything's done. Mind blank. Uh, We need to find the x's as well. Okay. Hmm. This is definitely not going to work. Great. Zero. Brilliant. Okay. We've got 10 minutes to find the bugs. Okay. Well, that's right. It's just not adding them. What's gone wrong here? Key error 8. Okay, fine. On 49. I want to go over here, I think. Hmm. 3974. Wrong. Okay. All right, let's actually find out how many galaxies we're yielding. Pairs. So there should be 36 pairs. Or 28. So that logic is incorrect. No, that's correct. Ugh. Okay, let's try the input. That number. Let's see. Okay, 26.55 or so. That, oh wow, I go outside of the box. Incredible. Um, all right. There were a few kind of quirks in there, mostly my own errors, but I don't think it affected the time dramatically. All right, let's find out what happens next. Ah, big numbers. The galaxies are much older and thus much farther apart. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. That is, each empty row should be replaced with 1 million empty rows, 1 million empty columns. In the example above, if each empty row or column were merely 10 times larger, the sum of the shortest paths would be whatever that is. 100 times larger, 8, 4, 10. Okay, well, that seems quite okay. Yeah, okay. So in our case, we just need to change the convolution, right? So instead of it being 1, it will be 1 million. Instead of it being 2, it'd be 2 million, 3, 3 million, etc. So we need to multiply the convolution by 1 million. Seems okay. I'm going to give myself a pause on this one. And I'm going to say, I'm going to try it out the simple way, or the way I think will work. And then if it doesn't work, then I will pause and we'll go back to the planning stage. When the challenges get a bit harder, I do start letting myself pause the coding and come back to it because often a bit of investigative coding is quite important when you get to these sort of challenges. Anyway, let's switch myself back. Remember to move my head over. Here we are. Delightful. And if I may say so about my own head, switch this over to 2. Get rid of that. Switch this over. Don't edit this. So go with this. And then I will restart the timer and we'll have a go. So let's start off with the 10. That will be 10:30 for the trial. We've got 1112. Well, it's not the right answer. Each empty row or column were merely 10 times larger. Oh, no, wait. It's actually 9 because we've already got 1, right? So we're only increasing it by 9. Yeah, that's right. So it's actually 10 minus 1. Okay, then it would be 100. It would be 80, 840, 8410, sorry. Okay, and so let's go with 1 million, which we don't have an example for, but we'll try it. Okay. Okay, let's try it with the input. which is not working for some bizarre. Oh, so you just save the file. Okay, let's try that. So you can see my reaction. Yay! Okay, I think I really aced part two there. Honestly, feeling pretty happy with that. Okay, that'll be it for today. I guess in terms of reflections, I was a little too many bugs on the ranges. Um, in particular, I think I might make my H range utility a little more explicit. Um, yeah, I figured them out in the end, but it just could have been quicker. And then this one was a little messy. I don't know why. I think I was just figuring it out as I went. Probably could have planned that a bit better, but otherwise fine. Pretty happy. Okay, see you tomorrow.